Every picture you've ever seen of the Milky Way is missing something. Not a star, not a spiral arm, something so large that once you see it, the familiar galaxy can never look complete again. Look at the Milky Way. A bright river of stars stretches across the night sky. Telescopes reveal a graceful spiral, its luminous arms wrapping around a crowded center. Beyond those stars lies darkness. The edge feels obvious. Nothing about the image suggests there's anything left to discover. For generations, astronomers thought much the same. The Milky Way was a spiral galaxy. Beautiful. Massive. Remarkably ordinary. Then they looked at it in a different kind of light. The spiral stayed exactly where it had always been. The stars didn't move. Only the boundary changed. Above the galactic disk, an enormous glow appeared. Another emerged below it. Not another spiral arm. Not another collection of stars. Something almost as tall as the visible galaxy itself. The photograph hadn't been wrong. It had simply stopped where human eyes had to stop. Visible light reveals stars. It cannot reveal every form of matter and energy filling space. So astronomers turn to wavelengths our eyes can never see. The first map traced gamma rays, the highest energy light in the universe. The result was astonishing. 2 giant lobes towered above and below the Milky Way, perfectly aligned with its center. At first, the discovery demanded skepticism. Large structures have appeared in astronomical surveys before, only to vanish when better data arrived. Extraordinary claims rarely survive extraordinary scrutiny. So astronomers kept looking. This time, not with gamma rays. With X-rays, the expectation was simple. If the gamma ray lobes were an illusion, the new observations would expose them. Instead, they made the mystery even larger. The inner lobes were still there. Now they were surrounded by another pair of enormous shells. Larger. Brighter. Stretching even farther into the galactic halo. Different telescope. Different wavelength. The same geometry. Both structures narrowed toward the exact center of the Milky Way. Both extended tens of thousands of light years above the galactic disk. Both reached just as far below it. Independent observations had arrived at the same galaxy. Not the one people thought they knew. A much larger one. The visible spiral had quietly become the narrow waist of an enormous hourglass, reaching far beyond the stars. Nothing inside the familiar photograph had changed. Everything outside it had. The Milky Way no longer ended where the starlight faded. It continued into structures no human eye could ever see directly. The hidden wings weren't small details overlooked by earlier astronomers. They were among the largest structures associated with our entire galaxy. The gamma ray lobes alone rise roughly 25,000 light-years above and below the Milky Way. The surrounding X-ray shells reach nearly 45,000 light-years in each direction, enclosing the smaller lobes inside them. Taken together, they span almost 90,000 light-years from end to end. Nearly the size of the visible galaxy itself. The discovery did more than redraw a map. It erased a comfortable assumption. The Milky Way was no longer just a quiet spiral floating through space. It carried the unmistakable outline of something enormous that had happened beyond the reach of ordinary sight. Finding those structures answered one mystery. It created another. If these hidden wings are truly part of our galaxy, what could possibly have built something so vast? The simplest answer comes first. Galaxies are not quiet places. Massive stars are constantly being born. They burn through their fuel in only a few million years before exploding as supernovae. Each explosion hurls energy into the surrounding gas. Enough explosions, spread across enough time, can drive enormous winds out of a galaxy. Astronomers see this throughout the universe. Some galaxies are surrounded by vast streams of hot gas, pushed outward by generations of dying stars. Perhaps the Milky Way's hidden wings were nothing more than a larger version of the same familiar process. At first, the idea seemed reasonable, until the measurements began to disagree. The first problem wasn't where the structures were. It was how much energy they contained. The hot gas filling the outer X-ray shells carries an estimated energy of around 10 to the 56 ergs. The number itself is difficult to picture. Its meaning is not. It represents one of the most energetic events ever linked to our galaxy. An ordinary collection of supernovae struggles to produce that much energy in a single concentrated episode. Then another clue appeared. Not in the numbers, in the shape. Look carefully at the giant lobes. Their edges remain remarkably smooth across tens of thousands of light years. The upper structure mirrors the lower. The larger X-ray shells repeat the same pattern. The symmetry is almost impossible to ignore. Nature can produce chaos. It rarely produces order on this scale by accident. If countless unrelated explosions had inflated these structures over millions of years, astronomers would expect something far less organized. Instead, they found two enormous forms that appear to have grown together, almost like the opposite halves of the same event. That raised another question. If ordinary star formation powered everything, where was the evidence it should have left behind? A galactic-scale starburst does not disappear quietly. It fills the central region with huge populations of young, massive stars. It leaves behind enormous numbers of stellar remnants. Its fingerprints remain visible long after the explosions have ended. Some of those fingerprints do exist near the center of the Milky Way. Just not enough. Not enough to explain the full scale of what now surrounds the galaxy. One possibility was beginning to lose ground. Not because anyone wanted a more dramatic answer, because each new observation made the ordinary explanation a little harder to defend. The structures were too large, too energetic, too symmetrical. The evidence wasn't pointing toward random activity spread across the Milky Way. It was pointing towards something far more focused. Something that released an extraordinary amount of energy from a surprisingly small region. The shape of the wings had been hinting at that from the beginning. Now astronomers looked at them differently. Not to measure their size, to find their origin. Trace the edge of the upper lobe downward. Trace the lower one upward. Do the same with the larger X-ray shells. The paths keep converging. Again and again, until every boundary reaches the same place. The galactic center. The giant structures don't rise from random locations across the disk. They emerge almost perfectly perpendicular to it. Their narrow waist sits directly above the heart of the Milky Way. That alignment changes everything. The hidden wings are no longer simply enormous objects surrounding our galaxy. They have become evidence of something that happened at its center. The mystery is no longer how large these structures are. It's what happened in the middle of the Milky Way that left scars stretching almost 90,000 light-years into space. The geometry was only the beginning. Another set of measurements revealed something even harder to explain. The giant structures aren't frozen in place. They're still moving. Gas along their boundaries is racing outward at more than 1,000 kilometers per second. That changes the picture immediately. These aren't ancient clouds drifting through the halo. They're the expanding remains of something that happened. Another observation deepens the mystery. The gas isn't merely moving fast. It's extraordinarily hot. Not thousands of degrees, millions. X-ray observations reveal shock-heated plasma reaching temperatures between roughly 1 and 10 million Kelvin. That's exactly what astronomers expect to find after an enormous release of energy drives powerful shock waves through surrounding gas. Now the clues begin reinforcing one another. The geometry points to the galactic center. The expanding gas points to a violent outflow. The hot plasma points to an immense explosion. Each observation was made independently. Each tells the same story. Something happened near the center of the Milky Way. Something powerful enough to reshape the galaxy far beyond its visible stars. The next question is obvious. When? Fortunately, expanding structures carry their own clocks. If the gas is still moving outward today, its speed can be measured. Its current size can be measured. Run that expansion backward, and the enormous shells begin collapsing toward the center. The outer X-ray structures contract. The inner gamma-ray lobes contract with them. Every path leads back to the same compact region surrounding the galactic center. The timing is surprising. Current models place the event roughly 2 to 6 million years ago. That sounds unimaginably distant. For a galaxy more than 13 billion years old, it is almost yesterday. The Milky Way already looked much like it does today. Its spiral arms already stretched across space. Our solar system was already orbiting the galaxy. Then something happened at its heart. Not across the entire disk. Not throughout the halo. In one remarkably small region. By now, the evidence has answered 2 of the biggest questions. The hidden wings are real. And they originated at the center of the Milky Way. Only one mystery remains. What could release enough energy to inflate structures almost 90,000 light-years across? Astronomers have spent years testing 2 competing reconstructions. The first begins with stars. Perhaps the galactic center experienced an intense burst of star formation. Thousands of massive stars formed within a relatively short time. They lived fast. They exploded young. Together, their combined winds and supernovae may have driven an enormous outflow above and below the galactic disk. The second reconstruction begins with something far more compact. Sagittarius A star. The supermassive black hole at the center of the Milky Way. Today, Sagittarius A star appears surprisingly quiet. It consumes only small amounts of matter. Compared with the brilliant active black holes seen in distant galaxies, it seems almost dormant. But black holes don't have to remain active forever. They can flare, then fade. If Sagittarius A star swallowed a large cloud of gas, or even a wandering star, a few million years ago, the sudden release of energy could have launched enormous outflows into the surrounding halo. Events like that have been observed in other galaxies. The Milky Way may simply preserve the fossil record of one. Neither explanation has been accepted as absolute certainty. Both are tested against exactly the same evidence. The age, the energy, the geometry, the expanding gas, the nested gamma-ray lobes, the surrounding X-ray shells. Today, the strongest evidence points toward a major energetic episode associated with Sagittarius A star. At the same time, astronomers cannot completely rule out that intense star formation also contributed to the outflow. The details are still being refined. The larger picture is no longer changing. A few million years ago, something extraordinary erupted from the center of our galaxy. The hidden wings are not random structures scattered through space. They are the scars it left behind. Return to the picture that started all of this. The familiar Milky Way. The bright band of stars crossing the night sky. Nothing about it looks different. The spiral still shines. The stars still occupy the same places. If you looked up tonight, you would see exactly what generations before you saw. Now place the complete map beside it one last time. The gamma-ray lobes remain. The larger X-ray shells remain. The visible galaxy now occupies only the narrow middle of a much larger structure. The stars were never the whole story. They were simply the only part our eyes could see. The discovery didn't change the Milky Way. It changed our definition of it. For centuries, our galaxy seemed like a vast island of stars surrounded by empty space. Today, that picture no longer survives the evidence. Beyond the visible spiral lies an enormous halo still carrying the imprint of a violent past. The giant wings tell us that the Milky Way was not always as quiet as it appears today. A few million years ago, an immense release of energy erupted from its center. The expanding outflow pushed deep into the galactic halo. Shockwaves heated gas to millions of degrees. High-energy particles filled enormous cavities above and below the disk. Different telescopes reveal different pieces of that event. Gamma rays illuminate the inner lobes. X-rays reveal the larger surrounding shells. Together they preserve the fossil record of one of the most energetic episodes our galaxy has experienced in its recent history. Astronomers are still refining exactly what triggered it. Whether the eruption was driven primarily by Sagittarius A star, by an intense burst of star formation, or by both working together, remains an active area of research. That uncertainty is part of science. It is not a weakness in the evidence. Because the evidence no longer depends on a single observation, the geometry is measurable. The temperatures are measurable. The expansion is measurable. The connection to the galactic center is measurable. Independent observations continue describing the same galaxy. Not the one we imagined, the one that has been there all along. That's what makes this discovery so unusual. Nothing visible in the night sky warned us that our galaxy once unleashed an outflow stretching almost 90,000 light-years across. Nothing in the familiar spiral suggests that enormous structures still surround it. The Milky Way hides one of its greatest discoveries in wavelengths our eyes can never see. Tomorrow night, the band of stars will still cross the sky exactly as it always has. It will still feel complete. It still won't be. Beyond the fading starlight, the hidden wings of the Milky Way continue reaching into the darkness. Silent. Immense. A reminder that sometimes the biggest discoveries don't come from finding a new galaxy. They come from realizing we never truly saw our own.